NEC Article 645.15b addresses switch connections, stating that switches should be connected so that the switch terminals will be dead when the switch is in the off position. However, there's an exception to this rule. The exception states that except when voltage testing and calibration procedures are being performed, the conductor connecting the switch to its supply shall be capable of being disconnected from the switch in the off position. This exception permits a small amount of voltage to be present on the switch terminals even when the switch is in the off position, specifically when the purpose is for voltage testing and calibration. The National Electrical Code, or NEC, does not specify the exact amount of voltage that is allowed under this exception. The reasoning behind allowing some voltage during testing is to facilitate the use of testing equipment like voltmeters and other calibration tools without requiring a complete disconnection of the circuit. A voltage of up to 30 volts is generally considered acceptable for voltage testing purposes. This is largely due to the design of most voltmeters, which are typically capable of safely measuring voltages up to this level without risking damage to the instrument. The 29 volts measurement falls within this commonly accepted range for voltage testing. In practical terms, the presence of a small voltage, such as the 29 volts measured, could be attributed to several factors. Firstly, it could be due to capacitive coupling. Capacitive coupling occurs when conductors are placed in close proximity to each other, creating a capacitor-like effect. This can induce a small voltage on the supposedly de-energized conductor. Secondly, inductive coupling may be a factor. Inductive coupling happens when conductors carrying alternating current are near other conductors. The alternating current in one conductor can induce a voltage in the adjacent conductor through electromagnetic induction. Thirdly, leakage current could be a cause. Leakage current is a small amount of current that can flow through insulation or other non-conductive materials. This current can create a voltage drop that can be measured. The specific reasons for voltage presence can depend on wiring, load types, and the environment. Troubleshooting steps can be taken when an unexpected voltage is detected. Firstly, ensure the testing equipment is functioning correctly. A faulty voltmeter can provide inaccurate readings. Secondly, verify the switch wiring. Incorrect wiring can cause voltage to be present on the switch terminals even when the switch is in the off position. Thirdly, examine the surrounding circuits for potential sources of interference. Nearby circuits carrying high currents or voltages can induce voltages in the switch circuit. Fourthly, determine if the voltage is truly problematic. If the voltage is low and does not pose a safety hazard, it may be acceptable, especially if it's within the acceptable range for voltage testing. Keep in mind that local electrical codes and regulations may have specific requirements that supersede or supplement the NEC. It is important to consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and regulations. Firstly, the NEC is a comprehensive set of guidelines for electrical installations, but it's not a substitute for professional judgment. Secondly, electrical work can be dangerous and should only be performed by qualified individuals who have the necessary training and experience. Thirdly, understanding the NEC is crucial for anyone involved in electrical work, as it helps ensure the safety of people and property. The NEC provides a framework for safe electrical practices, but it's essential to adapt these practices to specific situations. Consider the following point related to NEC Article 645.15b. Firstly, the exception provided in Article 645.15b is intended to allow for safe and effective voltage testing and calibration. Secondly, the voltage levels allowed are not explicitly defined, but a general guideline of up to 30 volts is commonly accepted. Thirdly, troubleshooting unexpected voltage readings is an important part of electrical maintenance and safety. It is essential to properly interpret the NEC guidelines and apply them appropriately in electrical installations and maintenance. Firstly, the NEC is not a static document, and it is updated regularly to reflect changes in technology and best practices. Secondly, staying current with the latest edition of the NEC is important for all electrical professionals. Thirdly, seeking clarification from electrical inspectors or other qualified professionals is always a good idea when dealing with complex or ambiguous situations. Remember, electrical safety should always be the top priority. Firstly, never work on electrical equipment unless you are properly trained and authorized to do so. Secondly, always use appropriate personal protective equipment, such as gloves and safety glasses. Thirdly, always de-energize circuits before working on them, and verify that they are de-energized using a reliable test instrument. The presence of a small voltage on a switch terminal in the off position, as described, is a common occurrence during voltage testing and calibration procedures. The NEC allows for this under specific conditions, and a voltage of up to 30 volts is generally considered acceptable for this purpose. Understanding the underlying principles of electrical circuits, as well as the NEC guidelines, is crucial for ensuring electrical safety and compliance. The NEC is a valuable resource for electrical professionals, but it should be used in conjunction with sound judgment and best practices. Firstly, always consult with a qualified electrician or electrical inspector when in doubt. Secondly, prioritize safety in all electrical work. Thirdly, stay informed about the latest developments in electrical codes and technology. It's essential to understand the context of the NEC exception. The exception is not a blanket permission to have voltage present on switch terminals in the off position under all circumstances. It specifically applies to situations where voltage testing and calibration procedures are being performed. The intent is to allow qualified personnel to use testing equipment to diagnose and troubleshoot electrical circuits without creating a hazard. If the voltage is present for other reasons, it may indicate a problem that needs to be addressed. In addition to the causes mentioned earlier, such as capacitive coupling, inductive coupling, and leakage current, other factors can contribute to voltage readings on switch terminals. Firstly, improper grounding can cause voltage imbalances in a circuit. Secondly, loose connections can create resistance that can lead to voltage drops. Thirdly, damaged insulation can allow current to leak to ground. If you encounter a voltage reading that you cannot explain, it's important to investigate further to determine the cause. Firstly, carefully inspect the wiring and connections for any signs of damage or corrosion. Secondly, test the grounding system to ensure that it is functioning properly. Thirdly, use a multimeter or other test instrument to measure the voltage and current in the circuit. The NEC also provides guidance on the proper installation and maintenance of electrical equipment to minimize the risk of electrical hazards. Firstly, Article 110 covers general requirements for electrical installations, including requirements for working space, guarding, and identification of equipment. Secondly, Article 250 covers grounding and bonding requirements to ensure a safe path for fault current. Thirdly, Article 408 covers switchboards and panel boards, which are important components of electrical distribution systems. By following the NEC guidelines and best practices, you can help ensure the safety and reliability of electrical systems. It is essential to approach electrical work with caution and respect, and to always prioritize safety. The NEC is a valuable tool, but it's not a substitute for knowledge, experience, and sound judgment. Always seek the assistance of a qualified electrician or electrical inspector when needed. This will ensure that the electrical work is performed safely and in compliance with all applicable codes and regulations. When applying the NEC, it is important to consider the specific characteristics of the electrical system and the environment in which it is installed. The NEC provides general guidelines, but these guidelines may need to be adapted to suit the specific circumstances. For example, the NEC may have different requirements for electrical installations in hazardous locations, such as areas where flammable liquids or gases are present. The NEC also addresses specific types of electrical equipment, such as motors, transformers, and lighting fixtures. These articles provide detailed requirements for the installation and maintenance of these types of equipment. In addition to the NEC, other standards and regulations may apply to electrical installations. These may include local building codes, fire codes, and environmental regulations. It is important to be aware of all applicable requirements and to ensure that electrical work is performed in compliance with these requirements. Electrical safety is a shared responsibility. Everyone who works with electrical equipment or who lives or works in buildings with electrical systems has a role to play in ensuring safety. By following safe work practices, maintaining electrical equipment properly, and being aware of potential hazards, we can all help prevent electrical accidents. The information provided is intended for general guidance only and should not be considered a substitute for professional advice. Electrical work should only be performed by qualified individuals who have the necessary training and experience. Always consult with a qualified electrician or electrical inspector before performing any electrical work. Furthermore, it's also very important to note the difference between different types of electrical testers. A basic non-contact voltage tester, sometimes referred to as a tick tester, is designed to detect the presence of alternating current voltage without making direct contact with the conductor. These testers are useful for quickly identifying energized circuits, but they may not provide accurate voltage readings. A multimeter, on the other hand, is a more versatile instrument that can measure voltage, current, resistance, and other electrical parameters. Multimeters can provide more precise voltage readings than non-contact voltage testers, but they require direct contact with the circuit. When troubleshooting electrical circuits, it's important to use the appropriate test instrument for the task. Non-contact voltage testers are useful for quick checks, while multimeters are better suited for more detailed measurements. In the context of the original scenario, the fact that a tester showed a dim light suggests the use of a non-contact voltage tester, while the voltmeter showed 29 volts. This highlights the importance of using the right tool for the job and understanding the limitations of each tool. The NEC is a complex and comprehensive document, and it's essential to have a thorough understanding of its provisions before performing any electrical work. The NEC is updated regularly, so it's important to stay current with the latest edition. The NEC is not intended to be a substitute for professional judgment. Electrical work should only be performed by qualified individuals who have the necessary training and experience. Always consult with a qualified electrician or electrical inspector before performing any electrical work. Always prioritize safety and follow safe work practices. Electrical accidents can be prevented by taking appropriate precautions and using common sense. The purpose of the NEC is to establish minimum safety standards for electrical installations. The NEC is not intended to be a design manual or a textbook on electrical engineering. The NEC is intended to be used by qualified electrical professionals who have the knowledge and experience to apply its provisions correctly. The NEC is a valuable resource for electrical professionals, but it's important to use it in conjunction with sound judgment and best practices. Always consult with a qualified electrician or electrical inspector when in doubt. Always prioritize safety in all electrical work. Stay informed about the latest developments in electrical codes and technology. The information provided is intended for general guidance only and should not be considered a substitute for professional advice. Electrical work should only be performed by qualified individuals who have the necessary training and experience. Always consult with a qualified electrician or electrical inspector before performing any electrical work. In summary, the NEC allows for a small amount of voltage to be present on switch terminals during testing and calibration procedures. The exact voltage level is not specified, but a voltage of up to 30 volts is generally considered acceptable. If you encounter a voltage reading on a switch terminal, it's important to investigate the cause and ensure that it's within acceptable limits. Always prioritize safety and consult with a qualified electrician or electrical inspector if you have any questions or concerns. The NEC is a living document that is constantly evolving to reflect changes in technology and best practices. It is essential for electrical professionals to stay current with the latest edition of the NEC and to understand how its provisions apply to their work. The NEC is not just a set of rules, but a framework for ensuring electrical safety and protecting people and property from electrical hazards. By understanding and applying the NEC correctly, electrical professionals can make a valuable contribution to the safety and well-being of society. This understanding of the NEC exception clarifies the common scenario of seeing a small voltage in a switch's off position, linking it to testing procedures and acceptable voltage ranges.